Students, today let us see the problems based on state space representation of discrete time system. So generally there are four methods. First one is controllable canonical form, observable canonical form, diagonal canonical form, and Jordan canonical form. Let us take the following example. So determine the controllable canonical state model of the system whose transfer function is given. So in this they have given us a transfer function that is T of s equals to 2 into s plus 5 by s plus 2 into s plus 3 into s plus 4. So first step what you have to do means you have to apply the partial fractions. For the given transfer function you have to apply the transfer function. So let us write this transfer function into partial fraction, that is a by s plus 2 into a by s plus 2 plus b by s plus 3 plus c by s plus 4. So from this you have to find out the values of a, b and c. So that is equals to 2 into s plus 5, that is equals to a into s plus 3 into s plus 4 plus b into s plus 2 into s plus 4 plus c into s plus 2 into s plus 3. So let us denote this one as equation 1. So from this equation 1 we have to find out the values of a, b and c. So for that let us first substitute s equals to minus 3. So if you substitute s equals to minus 3 in equation 1, so here you have to substitute, here wherever there is s, there you have to substitute minus 3. So let us substitute here. So s equals to minus 3, if you substitute minus 3 plus 3, that is 0. 0 into something is total term will become 0. Similarly here also s equals to minus 3, if you substitute the total term becomes 0. So then the equation becomes as 2 into minus 3 plus 5, that is equals to b into minus 3 plus 2 into minus 3 plus 4. If you solve this you got b equals to minus 4. Similarly now put s equals to minus 4 in equation 1. So if you put s equals to minus 4, again this equation becomes 0 and this equation becomes 0. So now you will get the equation for c. From this you can find out c, that is c equals to 1. Similarly if you substitute s equals to minus 2 in equation 1, you will get the value for a. So in this way you got a, b, c. Now you have to substitute that a, b, c values over here. In the given transfer function you have to substitute a, b and c. Let us see how. So after substituting we got T of s equals to 3 by s plus 2 minus 4 by s plus 3 plus 1 by s plus 4. So in the same problem let us see how to draw the state diagram. So if you draw the state diagram you can write the state equations also. So let us draw the state diagram. So you have to draw the state diagram as shown in the below figure. So to represent the first term, we have first term as 3 by s plus 2. So 3 by s plus 2, numerator we have 3. So just with simple block you represent that 3. How you have to represent this 1 by s plus 2? 1 by s plus 2 has to be represented as shown here. You have to use one integrator as well as one box. So this 2, if you bring it to the numerator it becomes as minus 2. So you have to represent as 2 which is given as an input to the summing point. So in this way s plus 2 is there, right, in denominator. This has to be represented by using two boxes. One is integrator, one is the element box. So this is an integrator, this is a box. So integrator is common, so you have to represent the element in this box, that is you have s plus 2, so represent that as 2. And you have to use one summing point. How you have to represent means 2, if you bring it to the numerator it becomes minus, so for this summing point you have to put minus. And here the output of this summing point you have to represent with x1 dot. If you integrate that x1 dot you will get the output as x1. So this is how to represent the first term. How? First you have to represent 3 with one box, and 1 by s plus 2 has to be represented by using two elements. One is integrator and the element box. Like this you have to represent, and you have to use one summing point. So this, if it is of s plus 2 then it becomes as a minus. If it is of minus then you can have to put the feedback signature as plus. And the input one you have to use. The input is u of t. So first one we have finished. Second one minus 4 by s plus 3, same numerator minus 4, it is represented in a box. 1 by s plus 3. So similarly 1 by s plus 3 means you have to use two boxes. One is the integrator and the element box. You have to represent. Here also we have s plus 3, so in numerator if we bring it to the numerator it becomes minus, so you have to put it with minus. You have used one summing point. This second summing point is represented with x2 dot. If you integrate this x2 dot you will get output as x2. Similarly third one, 1 by s plus 4, 1 by s plus 4, right, 1 and s plus 4 is represented like this with these two, and this third one you have to represent with x3 dot. If you integrate this you will get x3. In this way the total transfer function has been represented in state model. So for everything you have to give input, that is u of t, for first one, second one, third one. So in this way you have to represent. And finally this all output should be added to one particular summing point. So x1 if it is multiplied with this 3, what you will get? 3x1. x2 if you multiply with this minus 4, what you will get? Minus 4x2. If x3 is multiplied with this one, what you will get? x3. All these are adding. 3x1 is adding, minus 4x2 and x3. So what will be the final output? Y of t equals to 3x1 minus 4x2 plus x3. So this is your output and this is your input, right? So from this state model we have to write the state equation. So x1 dot equals to, so x1 dot where we have here. So for this x1 dot, how many inputs are there? 2. One is u of t and one is the feedback. So u of t, so u of t minus this x1 is acting as a feedback to this, so x1 into 2, that is 2x1. How it is adding? With minus. So u of t minus 2x1. What is the output equation for x1 dot of t? That is u of t as an input and 2x1 is one feedback which is adding to this. So we have written u of t minus 2x1. So u of t minus 2x1. Similarly x2 dot equals to u of t is input, 3 into x3 is adding. So these both are adding. So x2 dot equals to u of t minus 3x2. So u of t minus 3x2. Similarly x3 dot equals to u of t is one input and feedback is one input. So that is 4x3. So u of t minus 4x3. So in this way we got x1, x2, x3, and we also got the output equation over here. So we know the state equations, that is x dot equals to ax plus bu, y equals to cx plus du. Simply will represent in this form. So how many we have? x1 dot, x2 dot, x3 dot. So here x dot is nothing but the state equation. How many we have? x1 dot, x2 dot, x3 dot. So x1 dot, x2 dot, x3 dot equals to, so x1 dot equals to u of t minus 2x1. So let us represent this u of t later. So x1 dot equals to minus 2x1. So minus 2. Remaining terms 0. So because we don't have x2 and x3 over in this equation. So minus 2, 0, 0. Similarly x2 dot equals to minus 3x2. Only we have x2 terms. So 0 minus 3, 0. So x3 dot equals to, we have only x3 term. We don't have x1, x2. So x1, x2 terms 0. x3 is minus 4 into x1, x2, x3 plus B matrix. How you have to represent the B matrix? Something into u. So something into u means in x1 dot we have u of t, x2 dot you have u of t, x3 dot you have u of t. That is nothing but 1 into u of t, 1 into u of t, 1 into u of t. So 1, 1, 1. That is equals to, that is into u. Similarly y equals to same. x1, x2, x3 you have to write. Y equals to 3x1 minus 4x2 x3. So minus 3 minus 4, 1 plus D matrix is 0. This is how to represent the state model as well as state diagram whenever he asks you a question on controllable canonical form. So this is the procedure for controllable canonical form. First you have to apply transfer function, then after getting this transfer function you have to draw the state diagram and find out the state equation and represent in the matrix form, right? Thank you.